There's some keys here. So how do we do this? How do we separate this into the parts? Okay, because there's lots of options. Okay, so I could let the u part, so this is basically u dv. Well, what parts do I choose as u and dv? Well, I can choose u as 1, dv as the rest of it, cos x dx, right? Or sorry, x cos dx. If I let u be x, this part's my u, okay, this part must be my dv, okay, cos x dx. Okay, so then I've given you a bunch of options here. So which one is going to work? And how do I best choose how to separate it into parts? And the rule is this, okay, and this is key. Basically, we want to choose a dv. A dv in this expression, the dv that we choose is the most complicated integral that we are able to do. Because we're going to integrate this into a v part and differentiate the u into a du part. Okay, so we have to be able to choose a dv that's really hard to make the new integral easier. So here, this dv, I need to integrate this, and this is the original problem. I can't integrate this. This is why I'm using integration by parts. What about this dv? Well, this dv, yeah, I know how to integrate this. That's cos x. I know how to integrate this. I'm just going to maybe mark that one. What about this one? So u is x cos x and dv equals dx. Well, that's really easy. I can integrate that, no problem. But that doesn't really help me out because I need something that's hard to integrate that I can do. This one's harder, so I don't want to choose that one. Same thing here. This is my dv. I can, if I u is cos x, the remaining part is x dx. That's my dv. Well, if that's my dv, I can integrate it, but again, the criteria was the most difficult integral that I can integrate. When I compare these two integrals, this one's more complex. So I should choose that one. That's what I'm going to do. So how do I apply the formula then? So first of all, there's the formula. We don't really need to remember where it came from, but the first part is, do you know the formula? Okay, if you don't know the formula, at least have it on a formula sheet. There it is. There's my formula. There are parts to this formula. Okay, so how do I split it into parts? The parts I choose, and the part I need to choose is the u and the dv part here. The first two parts, I need to choose a dv that is the most complicated, and that would be this one here. The most complicated part that I know how to integrate. And I can integrate cos x. Okay, so that's going to be my choice. Now, we don't know if that's the right choice because we have to try these things out. The last part is, now we got to generate some parts. And the parts are these. So I have my u part, which I choose here. Okay, that's my u part in my original integral. I have a dv part in my original integral, so that's the part in my original integral. Okay, so there's my dv part. So I split it up into u dv from the original integral. I need some other parts for this formula. I need a v part. Well, to get v, I need to integrate dv. Okay, there it is. To get u, I need to differentiate u. So that's how I generate the other parts. I need to differentiate the u, I get du. So derivative of u is dx. The integral of dv is v, and that's how I'm going to get my other part here. And there's the 4 parts I need for my formula. So again, I need to know the formula. I need to understand there's 4 parts to this formula. The first two parts come from the original integral. The second 2 parts I have to generate du by differentiation, v by integration. Once I've built all these parts up, I then plug it into the formula. So here's my original integral that I couldn't do to start with, x cos dx. My uv parts are going to be u, v, so x sine x. And this new integral is going to be made up of the v part and the du part. Okay, this du part can have x's in there as well, but in this case it's just a dx. So I have sine x dx. There it is. There's my new integral. And this integral here is equivalent to my original integral. So whatever I get as an answer on the right hand side, is exactly what I should get for the left-hand side. So then I look. I need to ask myself, is this new integral here, is this easier to work with than what I started with? Yeah, I can integrate this. I can't do that. There's a big X through there. However, I know how to integrate sine. So I'm going to do this. So this is what I'm going to end up with. So whatever this integral here is equivalent to x times sine x minus, well, the integral of sine is going to be negative cos x. And then since it's an indefinite integral, I should add a plus c. So there it is. The integral of x cos x is going to be x sine x plus cos x plus c. Okay, perfect. This is now, I've integrated that expression which originally I couldn't integrate. Now I'm a little bit skeptical because there's just a bunch of stuff in that formula, so I better check this. So I'm going to check it by differentiating. So and we can do this all the time. Anytime we integrate, we can check by derivatives. So I'm going to differentiate this. So this is going to be my check. d by dx of x sine x plus cos x plus c. The derivative of that is going to end up being 1 times sine x plus x times the derivative of sine is cos, so x cos x, plus, there's my product rule here, plus the derivative of cos is sine, so it's going to be negative sine. Okay, and so negative sine x, and the derivative of plus c is 0. So when I work this out, those cancel out, and sure enough, I'm left with x cos x. That's my original derivative inside the integral. That's correct. Check. That all works out.